Okay, we're going to work on trying to figure out our the vocabulary and the things that we're going to need to know for the EOC. First off, when you look at this first board, okay, it says blank depends on blank. Let's remember, what do we know? X depends on Y. Well, first, let's go right here real quick. What in an ordered pair, which letter comes first? It goes X, then Y. Don't write anything down yet. Hold on. Be patient for those of you waiting out there. First off, right here, what letter is this right here, my horizontal axis? That is X, and Y is up here. Okay? What is X? Is X my independent or my dependent? It is my independent variable. Don't write anything yet. Y is my dependent. So looking at that, blank depends on blank. Y depends on X. Don't write anything yet till I tell you. Okay, so let's look at this right here. Here are the things that you need to have written down that you need to know. Y depends on X. We know let's try this again in here in my class. I know there's others on the video. You should be writing this down now. And this ordered pair right here, it goes X, Y. X is the horizontal axis. It is independent. It's also known as the input and the domain. Next, let's look at some other ones. Let's see here. What about here? Don't write anything down. Let's think about this real quick. What is dots? Discrete would be when they graph with dots. Okay, so all I'm doing right now is just kind of jotting down some things. We're brainstorming. Don't write anything down. So what would a continuous function look like? Well, it'd be a line. Okay. Well, you know, a lot of people say infinity, but that's not true, because all that it means is that between 2 points, it's every integer and fraction. This is continuous. Continuous does not mean that it goes on forever and ever. It just means that between 2 points, it contains every decimal and fraction. Up here in discrete has got to be a certain number. Okay? They've got to have a certain number of things. Whole numbers, things that you can't have half of. So let's think about some things. If we were graphing continuous, what type of things would be continuous that we would be graphing? What type of things would we graph that would be discrete? What have we done before that you can't have a half of? No, certain real life things. Like what? Like if we were talking about number of computers. You're either going to have one computer, 2 computers. How about people? Okay. Candy bars. We cannot go into Walmart and only have 25 cents and be like, hey, I only have 25 cents, so can I have just a fourth of the candy bar? Okay, yeah, it doesn't work like that, okay? You can't go to the movies with only $2 and say, can I just watch the first 45 minutes? Okay, they don't let you do that. You have to pay for the whole thing. Continuous, to have a continuous line, what type of things when we graph are continuous? How about time? Just because I want it to be 2:30 in the afternoon, so school is over, can poof, it turn to 2:30? No, you got to go through every minute of every day, and you have to sit there and listen to Miss Crawford all period long and be miserable for every second. Another one besides time is what? Distance. Yes. I want to go to Disney World. I can't poof show up. That would be awesome. Speed. You can't just go from 0 to 60. You have to gradually get there. What else? How about volume? What about volume? Like height, the number of feet, and your height. Yeah, you can't just automatically, poof, you wake up and you're 6'2". Okay, you can't go from 5'3" to 6'2" automatically. Okay, your weight. Yes, even though some people think that they just all of a sudden get fat. No, no, no. You have gotten gradually bigger. Your pants did not shrink, even though we say that. Okay, you gradually gained weight. All right, so let's look at what we could write down. There it is. Here we go. Now, here we go. Why don't we write these down? It says a discrete cannot cut in half. You can count them all, whole numbers and dots. Continuous, you can cut them in half. You cannot count them all. That's a good point. You cannot count them all. Remember, that's when I told the difference between like writing 0.9, 0.999999999, 0.9999999999999. Would you like to continue to write all the numbers between 0 and 1? Okay, yes, some of you would. Okay, good. We'll be here. That'll take up 2 hours. Okay, not at least, not a problem. Okay, so let's get this written down. All right, the next thing that we are going to look at, what does it mean if something's a function? It works? Well, not just that it works. How do you know if something's a function? Now, if it's a function, and this, I would star and highlight this, because this is one of the things that at the beginning of your test, before you ever start, I would write this down at the very top of your test. And here we go. A function is when we have a graph when there are no x numbers repeating. So let me see if I can write this well here. Let me draw my lines. So here's my coordinate grid. One of the ways you know if it's not a function. So if I have a line, and we have the vertical line test. That's one thing. Remember when we draw a vertical line, I know it's not a straight line, and it only touches through your equation once? This is a function. Okay? Now, if I have one that looks like, let's see. All right, drawing. There we go. Say, for example, we have something like this. And I draw a vertical line. It goes through it 2 times, right? This is not a function. Now, we have the vertical line test, but what it means is the reason why this is not a function. So, for example, maybe these points are, this point up here is 2, 3, and this one is 2, -2. What's the same in these two things? Out of these 2 points, what's the same? The x numbers are the same. This is saying that no x numbers can repeat. When we took a practice test before, you had a list of ordered pairs. Whoops, let's see if I can. We had a list of ordered pairs, and it asked you, is it a function? Okay, well, if it's a function, then the x numbers do not repeat. Do these x numbers repeat? This is a 1 and that's a -1. Those are 2 different things. This is an example of what is a function. If I had something like this, what about these points now, down here in the green? It is not a function because what repeats? What repeats? The -1 repeats, right? So that's what it means. When you're looking at this, and I promise, I am pretty darn sure it's going to be on your test, you need to make sure you have this down because the function, the x numbers cannot repeat. Next one, right here. Ooh, this one we should know. What are the parent functions? Don't write anything down. What's the linear parent function? Y equals x. Don't you write that yet in my class. Hold on. What's the quadratic function? Y equals x squared. Okay, so I want to make sure that you guys write down the right one with the graphs on it. Oh, we skipped, didn't we? What happened? What happened to it? Oh, there it is. Here we go. I would like you to write this down. There is the linear. Please make sure you notice that the linear parent function y equals x, it goes through 0, 0. It is an increasing function. Lines are increasing when the slopes are what? Positive. Increasing when the slope is positive. And when it's decreasing, the slope is what? It is negative. The slope is negative. Now, we will do this in just a minute, but what is that, this quadratic parent function, what's this thing called? It's called the parabola. What's the vertex? What is the vertex? The vertex is going to be the highest or lowest point on there, but we're going to have another little part that has that in there. So y equals x is a linear parent function. The quadratic function is y equals x squared. This is another thing when you first get your test that I would write down at the very beginning before you take any other part of your test. I would star and highlight this as well. This is something that I would make sure and do. I would write down this here too because I would make sure this is just something to help trigger your memory. When you talk about, I hear a lot of people say, oh, I can't study for a math test. Yes, you can. There's a lot of key concepts that you can study and review for. This is like studying for a final exam, and there's certain things that you need to remember. Linear parent function, quadratic parent function, standard form, slope, intercept. You have to know what all the vocabulary means on the words. Okay? Okay, so let's look at the next one. Another one we have right here. Slope, intercept, form. All right, so for example, what number goes here in this spot? The slope. What number goes here? The y-intercept. Now, do y'all remember what letters we use for these? M is the slope. B is the y-intercept. Okay, hold on. Let's see. So let me see what we have on the other official one here. That would not be the right. Well, I put 0 in B because, where did it all go? No. Because I'm crazy? No, not completely crazy. I know. Here's all my notes. I know I'm flipping through fast here. I'm trying to find. Oh, there it is. Oh, they didn't have a blank for that. Okay, so no, they didn't put 0B. What they did was they put 0 and a number. So, for example, if we have y equals 6x plus 2. First off, here is my slope. This 2, written as the y-intercept, is 0, 2. Now, why I want to make sure, remember we talked about some of those test questions, make sure that you understand that the y-intercept is written with the x right here as 0. It's always 0 and some number. Okay? If you had we could add on to our notes somewhere the x-intercept. The x-intercept is not in this equation, but if I wanted to write an x-intercept, I would have some number in the x and 0 in the y. You're going to have to know the difference about where the zeros are with an x-intercept and a y-intercept. Next. All right, what is standard form for a linear equation? Y equals a slope-intercept. What? AX BY equals C. This is standard form. This is standard form. That's why we're reviewing over this. And as you know that there are certain things you don't remember, You need to star and highlight that because we need to start looking at that to figure out what it is we need to review. Let me see if I can find my, we have done standard form, yes, right here. So AX plus BY equals C. That is your linear standard form. What we think is a lot of the answer choices are going to be written in standard form like this. You're going to need to know how to move them into slope-intercept. So right now, if you don't remember this right here, make a note on the back of your paper that we need to look at solving for y. That's where you take standard form and move it into slope-intercept form. So if you know that you don't really remember standard form, then make that note that we need to review solving for y. Okay? Next, let's see, what's my next one? Oh, here we go. Now, what does it mean to be parallel and perpendicular? All right, well, parallel, they don't cross. They don't cross at all. But what is true about their slopes? They should be the same. They should have the same slopes. Don't write anything yet. We're just brainstorming. Perpendicular, what does perpendicular mean? Well, when they cross at a what? A 90-degree angle. Okay, so let's look at a second and see what officially they want us to write down here. Oh, nope. Let's see. Oh, there it is. Okay. Now, I want you to write right here. It says the same slope, and you may want to make a note right here that there's your parallel. I'm going to talk about what opposite reciprocal means in just a second. Okay. So we have these here. If we're talking about parallel, we have, like, for example, these two lines. These two lines are going to be parallel because the slopes are the same, and I highlighted them right now. Now, what this means by opposite reciprocal, looking at the equations. So say, for example, I have y equals 2/3 x plus 4. Okay? And if they are perpendicular, opposite meaning this slope is positive, right? So it means it's going to be negative. Reciprocal means you flip over the fraction. So it means 3/2x, and it doesn't matter what the y-intercept is. That's not an important when we're talking about perpendicular. So right here, that's the example of opposite reciprocal. I would make sure that I had those examples down so I know what they mean. All right, the next thing we're going to look at. Oh, what about inequalities? Okay, let's brainstorm for a second. What is this symbol right here? It is less than. Don't write it yet. Hold on. What is this one? Less than or equal to? What about this symbol? Greater than or more than? And this one? Greater than or equal to? Okay, so wait, I know I want to see what else they have on there because there's some other things that I want to add on here when we're talking about it. There we go. That's what I want you to have. There's what's very important here. Let me put this down here. Okay, when it's less than, if you have something like y equals 3x, or not equals, what am I doing here? Less than. Try again. Y is less than 3x plus 2. This is going to be a dashed line, okay? And because it's less than, you shade below. Now, one of the things they're going to ask you about on here is on this boundary line, okay? When you graph this line before you shade, any point that is on this line is not a solution. Why not? Because it's not what? Does it say that it's equal to it? Does it say that it's less than or equal to? No, nothing on this boundary line is in the solution. It's only where it's shaded. Now, if this is confusing to you, you better star and highlight and say that you need to go over and find the videos and we need to review on inequalities. Okay? The next one, for example, I have y is less than or equal to 3x plus 2. On this one, everything on the line is a solution. Okay? It is a solution on the line if it's on the line or below. This one, the points on the line are not a solution. Okay? These notes, again, should help you realize what we need to look at to review. The next one, we would have y is more than or greater than 3x plus 2. Again, the points on this line are not a solution. The only things that are solutions are things that are above this line because it's greater than. Then the next one, y is greater than or equal to 3x plus 2. These are a solution on the line and above the line because of the equal to bar. Very important. I think if they ask you about points, a lot of times they're going to use the points that are on a dashed or a solid line. Most of the time, I think it'll be a dashed line because they're looking for you to mess up, not knowing that if it's on a dashed line, it's not a solution. Next. Okay, what is systems of linear equations? What does that even mean? When it's a system of linear equations, what is that? Systems mean how many? How many are there? A lot of them. And in algebra, we've only dealt with how many? We've dealt with 2. So, like, for example, we would have something like this, and they would ask us to find the solution. There are 3 types of solutions. What are they? The solution to a system of equations is where the lines intersect. You're either going to have where they intersect, they're going to have one solution, many solutions, or none. Okay, so let's look back here. Let's see if I can pull this up and find it. There we go. Let me start like this. Okay, so 1, what do you notice about when there is no solution? What are the lines? Parallel. They are parallel. This one, they cross in one spot. Your solution is that ordered pair. What's happening on this one? They're on top of each other. It's the same line. That means there's infinitely many solutions. Now, there were 3 ways that we solved. One was by graphing. Okay, so let me write over here. When it was graphing, it said both were in y equals. So an example of that would be something like this. Okay, when they were both in y equals, the easiest way to solve it was by graphing. Substitution was when one variable was by itself. And then, let's see, another one, let's see, golly gee willikers. Who says that? I do. I guess I'm old school. Golly gee willikers. And elimination, we also called it linear combination. Okay, we called it linear combination. And that was, remember when we had x plus y equals 8, and then x minus y equals 2? You would draw a line and combine these together. The y's would cross out. Those are the 3 ways. I think a lot of times people struggled with substitution. That could be something in these right now that if you don't remember, you need to highlight that we need to go back over. Next. What about this? Quadratics. Don't write anything down yet. Let's just kind of look and see. What is this? Let's see. What is this point right here? The vertex. What is the curve called? The curve is called the parabola. Okay. Wait, I heard it. What are these points right here? Symmetric points. Don't write anything down yet. What is this line? It's not the y-axis. It's over here. But it's going to be the axis of symmetry. Now, look right here. These are symmetric points as well, but what else are they? What is it crossing? The x-axis. So that means that they are the x-intercepts. X-intercepts. Let me see what they have on the notes that they want to make sure we all have. Ah, there we go. Okay. Oh, there's, because remember, this will be a good thing to add in there. They didn't add all this. We just said that these points right here were the x-intercepts, which is fine. So it was the x-intercepts, the roots. What was the other thing we called them? Solutions. There was something else. Oh, zeros. Whenever they ask, all four of those things mean the same. The axis of symmetry is right here. Again, we called this curve right here. It is a parabola. Okay. Even though there's not a line maybe on the paper, if you have the worksheet, there's not a line to put the parabola. You need to make sure you know that's what it's called. Right here, there's only 3 lines on your paper. That's fine. Go ahead and write them all down. I think they kind of forgot about writing x-intercepts, solutions, and zeros. Roots goes, same thing. You want to have roots on there. When they ask you for the roots, they're asking you for these points right here. Remember, that's when we set them equal to 0. We use a way to find the roots. A way to find the roots. One way was the quadratic equation. Okay. The other way was to factor. And set them equal to 0. Okay. If you don't remember what I'm talking about right here, then that's something we need to revisit. And we need to look at before that test. Flip your paper over for those of you that are here in my class. And I want to write down, I want to have us remember the quadratic equation. Let me write this down. Quadratic equation. Remember, I had my lovely song. Okay. Does anybody remember it? X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, you don't really have to worry about all this, about remembering the formula, because it will be on your formula chart for the test. But before you can find A, B, and C, what does your equation have to be like? It has to be in what form? It has to be in standard form. Okay, so wait. What is the quadratic standard form? Before we could, okay, standard form. Before we could solve anything in the quadratics to find the roots and zeros, it had to be set equal to 0, which for the quadratic was ax squared plus bx plus c equals 0. It has got to be set equal to 0 before you can ever find a, b, and c. Please make sure we have this written down. Next, right here. Oh, there's that standard form. All right, here we go. Standard form for that quadratic, ax squared plus bx plus c. Now, what it's saying is this number right here, this c, is going to shift it up and down. It's going to change where your vertex is. Okay? This number over here, we talked about this before a while ago. And if like we had, let's see, y equals, say it was negative x squared, that parabola would open downward. Okay? We talked about it making, if this number was bigger than 1, if it was a 5x squared, it makes it narrower. If it's a fraction, we said that fraction makes it fat or wider. Okay? The larger the number, the skinnier it is. Again, if you don't remember this, we need to talk about the shifts in the quadratics. Okay? How does it move? I'm trying to think. It'd be under characteristics of the quadratic equation. I can't think what unit number we had for this one right now. But it just basically you need to know about stretches and compressions. Okay, you have to know that the larger that number is in front of the x squared, the skinnier it gets. The negative only has to do with the direction. Does it open up? Does it open down? If it's positive, it opens up. If it's negative, it opens down. Okay? Next. Okay, proportionality. Direct variation and inverse variation. We already talked about this. Let me talk a little bit about the inverse variation. Was one of the last things we did. And it would be an example like 212, oh golly, 3 4, 4 3, 12 2. Okay, looking at those numbers, how they switch. Direct variation is when they're proportional. So let's see here. So like, for example, this equation would be y equals 2x. When it's a direct variation, well, let me ask this. When it's proportional, what does proportional mean? Proportional, it means it goes through what? It goes through the origin. See right here, 0, 0? It goes through the origin. Now, you have to remember, it must be linear first. It must be linear first. What in the world does linear mean? It means it has to be a straight line. The word line in there. Okay? Now, let's go over here. I would flip our papers to the other side. I'll come back to this one in a minute. When it's linear, if I have a table of numbers, X and Y, and I have points in there. Okay? How do I know from a table if something is linear? No, if the x's don't repeat, that's a function. If it's linear, it means it makes a straight line. To make a straight line, same rate of change, which means delta y over delta x is the same, which is the same as rate of change. So when you're looking at a table, you have to go and figure out delta y over delta x, plus 1, plus 1. Now, just because these are the same doesn't mean it's linear. You have to figure out the x, and you must divide those numbers. So delta y over delta x, 1 over 1, all of those have the rate of change of 1. This would be linear. If delta y over delta x is not the same, it is not linear. Okay? All right, so let's go back for a second. Okay, you can finish writing those notes on proportionality for direct variation and inverse variation. It's one of the last units we did. Next, growth and decay. Okay, when we go to growth and decay, first off, when it's growth, okay, my line, my curve looks like this and it's going up. This is growth. Well, duh, that makes sense because it's going up. Decay means it's going down. So we could have an example of like this. Okay. Now, with our growth, the formula for growth and decay, we had y equals a b x. Actually, let me move that to a different spot so I can write some more notes on there. Y equals a b x. First off, what was this a? This number right here would tell us the what? Initial population, initial amount of cells we start with. If you're talking about the growth of the rabbit population, how many rabbits are you starting with? This right here, that B, is your rate of change. The words we've used for rate of change have been like doubles, triples. Now, doubles and triples, this right here would be growth because it's going up. Okay? If we use words like half-life, this would be decay. Okay, when they use things like half-life. So, for example, when we're talking about growth, we have y equals, this would be an example. 2 times 3 to the x power. What is making that be growth is this number right here, that it is larger than 1. If it was decay, an example would be a half-life, which would mean I would use a fraction right there as the base. That's what would cause it to be decay. All right, next, let's look at this on the exponents. Now, I think on your paper there might be a couple things different, like on the divide part. So let's look at these one at a time. Okay, first, when you are adding, right here, when you are adding, you do not do anything with those exponents. This is saying that I've got 3x to the thirds plus 3x to the thirds. That means when you're adding them, all you do is add the coefficient. Okay? The exponent stays the same. Be careful with that. Next, on multiplying, you are going to go in here and you are going to multiply the coefficients But remember that you add the exponents. Okay? When multiplying the bases, add the exponents. Power to a power. Right here, well, you multiply the exponents, but, you know, a lot of times it's easier to take this right here. And what it's saying is 2x squared to the third power. It's saying 2x squared 3 times. Well, and then go through and multiply 2 times 2 times 2 to get 8 and add up those exponents. Sometimes it's easier to do that than to remember to go 2 to the third power and then x squared to the third power. Okay? Again, if you don't understand this, we better get on there and start reviewing before that test. Now, on y'all's paper that you have, I think this says to the third power, right? Okay. I'll fix that because up here, for those of you just watching the video, right here, when we are dividing, you subtract the exponents. Well, on y'all's that's out there, here's what I'm saying for those of you, I'll come back to this in a second. Y'all that's out there right now, yours says 3x to the 5th divided by x to the 3rd, correct? Okay. We have the 3. Subtract the exponents. So on yours, 5 minus 3 is 2. So we have x to the 2nd power. Okay? Subtract those exponents. All right, going back. Next. Anything to the 0 power is 1. And then the negative, that inverse, if you have a negative exponent, like for up here, this is in the numerator. Put it in the denominator and it changes it from positive to negative. Okay, make sure that you know these rules of exponents before the exam. Next, the next thing you need to know. Here we go, quadratic solutions. I have x-intercepts, which are, these right here are the, oh, I don't want to use that green pen. All right, let's do the highlighter. Okay, here are the roots and the solutions. It's where it crosses the x-axis. We can find that by putting it in the calculator and looking to see where the, you can go and look to see wherever the y number is 0. You can put it in the calculator. You can factor, okay? Factors are when we had like, you'd factor it and find like x minus 1, x plus 2, okay? And you would put x minus 1, set it equal to 0, x plus 2, set it equal to 0, and to find your roots, you would solve for x. And I did already talk about the quadratic equation, x equals negative b plus or minus square root, x equals negative b plus or minus square root b squared minus 4ac all over 2a. But remember that you don't have to have the quadratic formula memorized because that is on your formula chart. Okay, so we should have all that written down. Now, let me add, flip your paper over and let's look at something for a second. The last thing that I'm going to do on this video right here is I'm going to talk about slope. On slope, first off, if I have 2 ordered pairs, okay, I have 2 ordered pairs. How can I find the slope between these 2 ordered pairs? And I'm going to put it in a table. Okay, so let's put it in a table. I have x and y, and I'll put the points in there. 2, 3, and 611. So now to find my slope, slope is delta y, the change in y over the change in x. The change in y from 3 to 11 is plus what? 8 delta x plus 4 delta y over delta x. 8 over 4 is 2. Okay, so that's how we find slope of two-ordered pairs. If it was on the graph, if I had a graph, okay, oh, you went and found the equation? Good. If it was on a graph, so say, for example, let's see here. Oh. My lines aren't very straight here. Say, for example, I had these two ordered pairs. Okay, this is A, this is B. And I want to know the slope. One thing you could do if you wanted to find the slope was build a table. This ordered pair right here is 0, 2. This one right here is 2, 0. You could put this in the table and do delta y over delta x. You can find it that way. How can I find it just on the graph? To find the slope on the graph, delta y, the change in y is how it's going up and down. Right here, here is delta y. What's happening? I'm going up or down from A to B. I'm going down 2, so this is negative 2. Well, guess what? Here it is right here, negative 2. Then I go across right here. There is delta x. That is plus 2. Well, look, up here, delta x plus 2. So I can look from a graph or the table. It's still going to tell me delta y over delta x, negative 2 over 2, negative 1. Okay? The last little bit about that slope, I can have, let's see here. Let me draw some little doohickeys here. What are these doohickeys called? Coordinate grids, coordinate planes. Okay, there are 4 different types of slopes right here. First off, I can have an example of a positive slope, which looks like this. This is a positive slope. We could have a negative slope, right? What about something that has a 0 slope? What does that look like? A 0 slope is a horizontal line. 0 slope is a horizontal line. Okay. Another type would be a, if it had no slope. No slope is when it is a vertical line.